You know, when you chat with modern AI tools today, it feels, well, eerily human, right? It cracks jokes, it writes code for you, it even consoles you when you're stressed out. It gives advice that sounds exactly like it's coming from a living, breathing expert. And honestly, it's just so incredibly good at what it does that it forces us to pause and ask a somewhat terrifying question about what is really happening behind the screen.
I mean, it's so easy to be completely fooled into saying please and thank you to a polite chatbot. It almost feels like there's a tiny, very helpful person trapped inside your phone. If you ask a tech executive what's going on, they're going to throw around complex jargon about billions of parameters. If you ask a sci-fi writer, they might tell you we're witnessing the birth of a digital soul. But the truth? The truth is actually much weirder, and in a lot of ways, way more impressive. Let's just be totally clear up front. AI doesn't experience the world. It doesn't have an inner monologue. It literally doesn't know what a sandwich tastes like or what heartbreak feels like. So what exactly is it doing when you hit enter? Well, our goal for this explainer is to peel back the curtain on the digital brain and find out.
Okay, let's dive right into this. To demystify the magic of AI, we're going to look at three core acts: turning words into numbers, the digital engine, and finally, context through self-attention.
Starting off with Act 1, turning words into numbers, the concept of embeddings.
So, here is the fundamental problem. A computer cannot read words or look at a photo or listen to a song the way that you or I do. To a machine, absolutely everything has to be converted into a language of numbers. If I give you the words king, queen, and apple, your brain instantly groups the first two as royalty and the third as a piece of fruit. But how on earth do you teach a machine to do that? Well, AI solves this through something called embeddings. Think of this as plotting every single word in the dictionary into this vast 3D digital universe. It takes a word and assigns it a massive string of numbers. That string acts as a specific coordinate in this mathematical map. And in this incredible digital universe, words with similar meanings are placed physically close together.
Now, what's really interesting here is how this proves that AI reads grammar as a dense geometric landscape. In this mapped-out vector space, the word king sits right next to the word man. The word queen sits right next to woman. So if you literally do the math, you take the coordinates for king, subtract the coordinates for man, and add the coordinates for woman, you land perfectly next to the word queen. It's mind-blowing. Before the AI can process a single sentence you type, it breaks your prompt down, translates those fragments into spatial coordinates, and reads your ideas purely through these astonishing mathematical relationships.
Which brings us to Act 2, the digital engine. Let's look inside neural networks.
Okay, so the AI has successfully turned your text prompts into mathematical coordinates. Awesome. But what exactly does it do with these numbers once you hit submit? How does it actually process them to give you a coherent answer? Well, it uses an artificial neural network. On the far left side, you have the input layer. That's where your prompt enters. In the middle, those sections represent the hidden layers. That's where the heavy lifting happens. And on the far right, you have the output layer that spits out your final response. Basically, this structure is a heavily simplified digital version of a human brain.
To really understand those hidden layers, I want you to imagine a massive stadium full of people, where every single person is holding a dial. The input numbers from your prompt are passed from the first row of people to the second row. Each person looks at the number, multiplies it by a setting on their specific dial, which engineers refer to as a weight, and then passes it to the next row. But you have to keep in mind the sheer scale of this operation here. We aren't just talking about a few thousand people in a local sports arena. No, we are talking about billions, sometimes trillions of simulated connections, turning their dials simultaneously in fractions of a millisecond.
Now, when an AI is first built, all of those millions or billions of dials are completely randomized. If you ask it, what color is the sky, it might spit out the mathematical equivalent of banana. It's just making totally random guesses. But during its training phase, it's shown billions of pages of human text. Every single time it guesses wrong, a supervisor algorithm steps in and flags the error. It tells the network exactly how far off it was. The network then works backward in a process called backpropagation. It suddenly, carefully adjusts every single one of those randomized dials until it finds the correct path to the right answer.
After repeating this process literally billions of times, the network doesn't actually learn a rigid programmed rule like the sky is blue. Instead, it simply tunes its vast mathematical pathways so perfectly that the correct answer naturally flows out when prompted. It's exactly like tuning a digital guitar. When you strum it with a specific question, the correct answer is just the natural mathematical resonance that hums right out of the instrument.
All right, let's move to our final technical act, context through self-attention and the big transformer breakthrough.
Now, you might be wondering, if the AI is just matching mathematical paths, why is it so incredibly good at keeping track of long, complex conversations? Historically, older AI models had a huge problem. They would actually forget the beginning of a long sentence by the time they reached the end of it. If you said the word bank early on, it might think of a financial institution, even if you ended the sentence talking about a muddy river. To see how the transformer breakthrough solves this, consider this first sentence. The animal didn't cross the street because it was too tired. To a human, it's obvious that the word "it" refers to the animal. But if we change just one word at the very end, so it reads, "The animal didn't cross the street because it was too wide," suddenly the entire meaning of the word "it" shifts. It now refers to the street. How on earth does a machine figure that out?
The answer is a breakthrough mechanism called self-attention. Self-attention allows the AI to look at every single word in a sentence simultaneously, rather than reading them one by one. This lets it figure out which words have the tightest grammatical connections to each other. When it processes the word "it" in that first sentence, the AI's internal mathematical dials flash brightly toward the word "animal." But in the second sentence, based purely on the surrounding context, those dials flash toward "street." It is perfectly mapping the grammatical relationships and dependencies.
This context awareness is the absolute secret sauce of modern artificial intelligence. The AI dynamically understands that the meaning of a word relies entirely on the word surrounding it. And because of this transformer architecture, it can analyze massive blocks of text. We're talking entire essays, sprawling legal documents, thousands of lines of complex code, all at once, instantly, without ever losing the plot or forgetting where it started. It's a real game changer.
Which brings us to our final conclusion. A mirror, not a mind.
We've gone through the embeddings, the vast neural networks, and the attention mechanisms, so it's time to strip away the final illusion and return to our initial question, how does an AI actually think? The simple answer? It doesn't. Not at all. It doesn't have sudden flashes of inspiration. It definitely doesn't sit around wondering about the meaning of life when you log off for the day. At its core, an AI is just an incredibly advanced statistical engine. It takes your input, converts it into coordinates in a mathematical universe, runs it through trillions of carefully tuned dials, and just calculates a statistical prediction of the very next, most logical token.
But here is the truly mind-blowing realization. Even though it is just math, the machine only looks incredibly smart because it is perfectly reflecting the human literature, human history, and human conversations it was trained on. When you look at an AI's response, you aren't looking at an alien mind waking up inside a silicon chip. You are looking into a massive, breathtakingly complex mathematical mirror of human intelligence. It mimics our collective patterns so flawlessly that it creates the ultimate illusion of a digital soul.
And that leaves us with one final thought to ponder as we wrap up this explainer. If we can create something this eerily human just by teaching a machine to guess the next word using complex geometry, will we ever build an AI that truly thinks? It's a fascinating question about the future of technology, one that completely blurs the line between mathematics and the mind. I hope this deep dive helped clear up the magic behind the screen, and I'll catch you in the next one.